Welcome to Walkabout the Galaxy, the indefatigable astronomy podcast, where the science is universal, the opinions are personal, and the trivia is speedle. We are Strange, Charm, and Top the Astroquarks, also known as Josh Caldwell, Addie Dove, and Jim Cooney, coming to you from the Walkabout Studios at the University of Central Florida. Today we are joined by Dr. Brad Sandor, planetary scientist at the Space Science Institute in Boulder, Colorado. Brad, welcome to Walkabout the Galaxy.
Great to be here, Josh.
Thanks for joining us. Jim.
Yes, sir.
IBM or HAL? Oh, you're befuddled?
Well,
just by the question.
What's the relevant? HAL's good.
Okay, you don't know what I'm talking about?
IBM's
Shame on you.
IBM is a computer company.
And
Correct.
HAL?
And HAL is the computer on 2001: A Space Odyssey.
Right, and there's a myth.
So why? Oh, I don't know what the myth is.
That if you take H, what's the next letter?
I.
If you take A, what's the next letter?
B.
If you take L, what's the next
M.
letter? But Arthur C. Clarke
I'm so good at
says
the alphabet.
That's actually not what he was thinking at all.
He just
named
wanted to name it Hal, and then
Yes.
it became
And then
and
people
that was a
said,
acronym.
hey, you know what?
Huh.
If you go HAL, one more.
Is it an
It's
acronym
IBM.
for something, or is it just?
It is.
Like,
heuristic
That's right.
something.
Yeah.
You know Brad? Brad has got
I do know Brad. He's right here.
He's got encyclopedic knowledge of arcane things, like what HAL stands for.
But I don't know that one.
Oh, so not like what Hal stands
Yeah.
for.
No.
Other things.
Things like it, but
Things
not
like it.
that thing.
I
Right.
will tell you that when you watch that movie at the University of Illinois and you are told that Hal was turned on at the University of Illinois, the
There's
audience
cheers.
will go wild.
Oh.
Cool. You've experienced this firsthand?
I have seen this.
Cool. Addie,
Hi.
TARDIS or tardigrade?
Tardigrade.
Tardigrade. Yeah.
That's an
Okay.
easy one for
All right.
Addie.
Okay.
Yeah. Tardigrades are, of course, water bears. They're these tiny little organisms that can survive in like all sorts of crazy extreme environments. I've talked about them before. And then TARDIS is from Doctor Who, which I don't really watch.
It's the
time
police
ship
phone booth
thing.
thingy.
Yeah.
Well,
I
it's
think
more
we've
than that,
admitted
but-
to being bad nerds before, but I don't
By
think
not
any of
watching
us
Doctor Who.
regularly watch Doctor
We
Who.
do not
I'm
have
tempted to watch the new season. There's a lady doctor.
Yeah.
A woman doctor.
a lady doctor.
A lady doctor does different things.
Go see the lady doctor.
That's what I say. I have to do that.
We don't
You
have
guys never say that.
we don't have good Doctor Who cred.
No.
Tardigrade.
Do you have Doctor Who cred?
I don't, but I do think the TARDIS is cool, bigger on the inside than the outside.
Exactly, yeah.
Oh, right.
It's like a Mary Poppins bag, but a spaceship.
The tardigrade now also ties in somehow or other with Star Trek.
Oh, that's true. The new Discovery.
Because in Star Trek Discovery,
They
there's
use
giant spacefaring tardigrades
Yeah.
that actually are the size of bears.
Yeah,
Yeah.
they're pretty awesome. I haven't watched all of that still, but I did like that one part.
And they look exactly like
Tardigrades.
tardigrades, which are, how big is a tardigrade?
You have to use a microscope to see it.
I
Yeah.
don't know that. I think
they're
they're like half.
Sub-millimeter.
Yeah, a third of a millimeter or
Yeah.
something like that.
Okay, so
Like you could tell if there was
see
something
it.
in water.
If you really
If
knew
there
what you
are
were
a bunch
looking
of
for,
them,
and they were
you
like
would see a
colored or
dot.
something. Yeah.
Yeah.
It's not like bacteria.
No.
No.
Right.
They're bigger.
And what do they live off or on?
All kind of stuff. You can find them in ferns very often, if you or moss and things
Oh,
like
really?
that. Lichen.
Am I going to find them like in my pillowcase though?
I don't know.
You
You
might.
should put them there.
That's an
You
unlikely.
can
place, I
irradiate
think.
your pillowcase and still find them there.
Okay,
So I hope they're
we'll
not
try
there.
that out. Brad, you're going to get a stumper. Classical mechanics or quantum mechanics?
Classical mechanics.
Oh, that was a robust answer.
That was robust.
Do you have a reason?
Because a large part of me is firmly rooted in the 19th century, which
Okay.
is well before quantum mechanics came onto this planet to confuse people.
I like it.
There you go.
NASA has selected the landing site for the Mars 2020 rover in...
Mars
the-
2020.
Actually in 2021.
I know, yeah, they moved it a little bit.
The launch is
The launch
2020.
is 2020, yeah.
Landing, I think, is in February 2021. And the landing site is called,
Jezero
I want to say
crater?
Jezero Crater, because
That's
that's
not-
the way it's spelled.
The correct pronunciation.
But
apparently.
it's named after a town in the
World.
Balkans.
Balkans.
I was having a
Are you doing
brain
an
freeze
improv game
between-
right now where
I-
you're starting a word and
That's
Brad has
right.
to finish it?
I was having we were looking at each other. I was like, it's either Baltic or Balkan, and I was having a little Balkan. Peninsula. Yeah. So, and so therefore, of course, it's pronounced very differently. Probably has no vowels, actually, either. But this is a crater with, of course, the site of long-lost water on Mars. And speaking of landing on Mars, Mars Insight
in a few days
is landing on November 26th, which may be in the past, dear listeners. And so if it is in the past, I hope the landing went well. If it didn't, you can just fast forward to the parts where we talk about how cool Mars Insight is.
Oh
no.
Oh.
I'm sure it's going to go fine. We've had a pretty good run with Mars.
Don't jinx it! Stop it! You're jinxing it. Get overconfident. That's when things crash.
Yeah.
Or your unit's wrong and
right.
Things crash.
There's new cool results from the European Space Agency's Gaia mission, which is this star mapper we've talked about. Which is, when you describe Gaia, it doesn't sound like a very exciting mission. It's like, we're going to measure very exactly where every star is, like just the direction to every star, very precisely. But then if you do it again, you see which way the star is moving and how fast it's moving.
Yeah.
And you can get some interesting
Creating
results
cool
from that.
3D maps of our environment. That's
galaxy.
awesome.
And it's measured over 1 billion, I think maybe now over 2 billion stars.
Yeah.
Still about 1% of the stars in the galaxy.
Yeah.
Nevertheless, pretty amazing. Another super Earth story. Space news.
Space news.
Have some space news and trivia. But first, this episode of Walkabout the Galaxy is brought to you by Jezero Crater.
Oh.
This Noachian crater in the Syrtis Major Quadrangle is a lovely destination for robotic rovers. With its ancient river delta and an abundance of carbonates, Jezero Crater has everything needed for life, except for everything needed for life. Jezero Crater is thrilled to welcome NASA's Mars 2020 lander, landing in 2021. Take the Jezero Trail for a scenic view of the river delta, or maybe first take the Northeast Walkabout to visit some lumpy things in the middle of the crater before heading what would have been upstream 3.5 billion years ago. Take a walk back in time at scenic Jezero Crater, the official NASA Mars 2020 rover landing site of Walkabout the Galaxy.
Oh.
No other NASA Mars 2020 rover landing site
It's going to be our sponsor.
will be our sponsor.
It's good to know.
This is they have the exclusive rights to that
Awesome.
claim. Brad, so you and I went to grad school together in Boulder. Have you guys been to Boulder?
I have.
One time! I went last month. It was fun. Very pretty.
Yeah.
It's very nice there.
You're a planetary scientist, but you've been studying the atmospheres of Venus and Mars primarily, right?
Venus,
Yeah, what's our
Mars.
buck? That is planetary science.
Yeah. Is it? Is it really?
By default, it is.
Venus is a planet. Am I missing something?
As is Mars.
Yeah, but atmospheres?
Are rings planets? No.
No.
All right. So Venus.
Venus, Mars, and Earth. Currently in that order, but wherever the money is, wherever the science is, yes, that's what I do.
And so you collect data, you make observations of Venus's atmosphere from
the James Clerk Maxwell Telescope on the summit of Mauna Kea, Hawaii.
Correct.
Ooh.
Yes. And that telescope is a submillimeter, so it's not really taking pictures the way we think of it. Although I went up there a couple times with you, and you sort of get some kind of picture, but it's like 3 pixels by 3 pixels on the planet, something like that.
There are a couple of imaging instruments, one of which is a bolometer, which doesn't do spectroscopy, so it's kind of boring. They do have 1 million pixels, and they brag about it because it has 1 million pixels, but there are no spectra, so, who cares? We use a spectrometer array which has 16 pixels, 4 on the side.
Right, and Venus usually does not fill that 4x4 array, as I recall.
Venus never fills that 4x4 array. At its largest size, we can put 4 of those sensors on the planet simultaneously.
Okay.
And we often do that at inferior conjunction when Venus is as close to Earth as it gets.
Right.
Other times we put together larger pictures by pointing one sensor at multiple different places.
And you're looking at emissions from the upper atmosphere from like sulfur compounds, SOx
We, technically speaking, we are looking at absorptions as the...
What about non-technically speaking? We
non-technically
don't speak
speaking...
technically on this show. So.
Absorptions.
Yeah.
Okay.
The Venus lower atmosphere emits spectrally flat, spectrally boring things, the kind of thing you would look at with a bolometer if you interested you.
Oh.
Somebody's got a grudge against bolometers.
But in the upper atmosphere, the air is colder than in the lower atmosphere. So that warm lower atmosphere emitting boring, spectrally flat
so all the heat,
emission, all the action is in the upper atmosphere.
Okay. Yeah. There's no funding agents are listening to this show though, Brad. So you're okay. Don't need to make the sales pitch.
Okay.
I like
Okay.
the sales
Your
pitch. It's good.
So
Now I know.
I'm teaching.
Lower atmosphere is boring.
I'm teaching a climate change course this semester, so we're talking about how heat tries to leave a planet, and Venus has an abundance of heat. So you're basically looking at some compounds in the upper atmosphere of Venus that is absorbing some of the heat that's trying to get out from the very, very hot lower atmosphere.
That is right.
Yeah, how hot again?
The surface of the planet is roughly 900
It's
degrees
so hot.
Fahrenheit,
That's pretty
which
hot.
is, I am told, hotter than a surgical autoclave, which is what they use
To
to
sterilize.
sterilize surgical instruments. So people ask me, do you think there's life on the surface of the planet?
Prob-
Probably not.
What about tardigrades?
Even tardigrades?
Even
Tardigrades are really tough, but I have never heard of one surviving an autoclave.
Okay.
Okay.
But what about the atmosphere? Couldn't things live in the
Higher up in the atmosphere.
higher up
things
in the
live.
atmosphere?
We have claimed
You
on
have?
this show
Oh, that's true. We have.
that there is an altitude in Venus's atmosphere where you can survive without a pressure suit.
Right.
That is
Well, there has to be that. But
Well,
Yeah.
it doesn't have to be that.
well, that pressure-wise, I mean, there has to be some
Pressure-wise.
point where it's, but it also has to be
Only
roughly right temperature. Is that the case? So
is it
where
roughly
it's
the right temperature?
At least-
Probably close enough if you're wearing parka. Yes.
all right.
Okay, so it'd be cooler.
It would be cooler. The atmosphere would also be acidic and corrosive.
Sure.
So breathing.
So you wouldn't need a pressure suit, but maybe you'd want like an acid
You'd
suit.
want an oxygen tank, and you'd want a what?
An acid suit.
An
An
acid
acid
suit.
suit.
Anti-acid suit? I don't know.
But there could be life there,
Hazmat suit?
potentially, right?
Yeah.
All right.
There's a lot
That's
of
all I
like
wanna know.
balloon mission ideas to send things to Venus to look at its atmosphere.
Yeah, that would be really cool.
Life in the atmosphere. you
Yeah.
mean?
Life in the atmosphere. I mean, it's not like the most likely place in the solar system you'd look. There
But
are
it's
probably
not the
places
least
to go for
likely.
it, but it's not. Yeah, I mean, it's conceivable.
Right, and it's a tougher. It is. I guess the atmosphere isn't impossible to look. The surface is bad because, as you say, the temperature is so high,
And the pressure.
and the pressure. It's not a nice place,
Not
and there's
great.
not a lot of sunlight to power stuff. Yeah, I guess you bring nuclear along.
I usually
things
do.
that way. Yeah. Space news.
Space
Maddie, did
news.
you hear the space news about SpaceX?
The renaming
Yes.
or the crew mission launch.
The renaming, but we should mention the crew mission launch. So we've talked previously about the BFR, the SpaceX BFR, the Big Falcon rocket, and that thing is, I'm telling you, Falcon huge. But it has been renamed.
Been renamed. I think this was one of Alon's like middle of the night tweeting kind of things. He renamed it. He was like, "I've got a great idea, you guys.
What did you rename it?
Starship or the Super Falcon?
Super Heavy.
The Super Heavy.
It's got two. It has both of those names. So
I think it has both. Yeah.
the booster part is called, or something is called the Super Heavy,
Yeah.
and then the part with the people in it is called the Starship.
Starship.
The Starship?
The Starship.
We'll soon
I think-
have
what?
real life Starship
yeah.
Troopers.
With the Space Force.
Yes, maybe he's angling for Space Force contracts
Maybe he
by
is.
having Starship,
And
and
then they can have
it
troopers
has
on
some
them.
troopers on there. Also, Rocket Lab.
Wait, but so then the
other
uncrewed
space-
other
SpaceX space
SpaceX in addition, so SpaceX has been flying to space station for a while, but just with cargo. But they have a different capsule, different Dragon capsule. That's the crew capsule, and it will have its first test flight,
uncrewed.
uncrewed, on January 7th.
It's very
Very
refined.
soon. It's
not-
uncrewed.
it's
It's,
not
very
crude.
refined. And so January 7th, and then there's going to be like a pad abort test in February, I think, and then
And the crewed.
the crewed launch. So with humans aboard,
Have they
going to
picked the
ISS.
humans?
Yeah.
Oh yes, that was a big announcement a few months ago. We talked about that, Jim.
I don't remember such a thing.
So this
Yes.
flight test
I
will
deny that
have.
happened.
I forget who the. Okay. Demo 2 will have NASA astronauts Bob Behnken and Doug Hurley.
Just 2 people?
Yes, and that's in June.
And are they going to ISS?
They're going to ISS.
Okay.
Yes.
Cool.
Awesome.
And then similarly, the Boeing, the CST, the Starliner, which is the Boeing's capsule,
right.
is supposed to do a test in March.
It's much less crude.
It's less. It's also an uncrewed
Starliner.
test. And then they have a similar schedule, but like a couple months behind what SpaceX is looking at right now. But it could be a very exciting year
for U.S. Human spaceflight launches.
Bring it back. Bring it back.
The last shuttle launch was 2012.
It was 2011, I think. It was right before I got here.
Okay.
And I came here in 2012, so it could have been 2012.
I think it might have been the summer of 2012, but in any event, it's been several years since U.S. astronauts have launched on a U.S.-built rocket. And previously, of course, they've all been launched on rockets that were developed by NASA, although it's important to remember, I think, that even those rockets had lots and lots and lots of hardware built by private companies.
Sure.
July
It's just
10, 2011.
Okay. So it's been 7 years plus.
It'll be almost exactly
8
years if they launch in July or June.
next year, right. But these are now be going on rockets that were entirely developed by private companies, but with funding from NASA and to meet NASA requirements on what a vehicle must be like in order to have people on board for NASA's purposes anyway.
Exciting.
Other space rocket news, there's lots of rocket
Rocket Lab launched again.
Yes. Their rocket's called the Electron.
The Electron rocket. They're launching out of New Zealand right now.
That's better than Starship.
You don't like Starship? You're really anti
It's like
Starship?
that because that's just a generic
just
term
a
for a
generic
Starship.
It is really annoying.
I mean, you have something.
Well, maybe each one,
Maybe
each
each one,
individual
it'll be
one will
like-
have a fun name.
You know what the first one's going to be called?
What?
Enterprise.
Enterprise.
Yeah.
I guess I'm on board with that. Enterprise.
Is that the one that they never actually fly, but just put it in a museum somewhere?
Right.
Yeah.
Because it's been tested to the point where
That's
Maybe.
it's no longer
Yeah.
flyable?
That's what we got stuck with the
The
shuttle.
other
That
Enterprise.
is.
Virgin Galactic's first Spaceship 2 was also named Enterprise, and it had a terrible crash,
Oh no.
so it was lost.
Virgin Galactic did a captive carry test of its rocket with its airplane recently.
Launcher 1.
Launcher 1.
What
So
is
this is
captive
like-
carry mean?
So there's two different. So Pegasus is a rocket that already exists. That basically it's a rocket that gets carried up on an airplane. So it's like the airplane's got its wings out and then it's holding a little rocket underneath its wing on one side. And so Virgin's developing their own, and it's called Launcher 1. And so captive carry was just like it took up the rocket and carried it along and then landed.
Yeah, it's to launch small satellites.
Yes.
And it
As
will,
is Electron.
right. And so there's a growing market. We talked about CubeSats, things like that. So some of the way those things get up into space, the way Addie's CubeSat got up, which was piggyback on a big rocket taking a big satellite up, but then there are also these new rockets that their entire purpose is to carry one or more tiny satellites, sometimes maybe 10 or 10 even of small satellites up into orbit. Hey, astroquarks.
Hey, other astroquark.
Walkabout the Galaxy is also sponsored by Girl Powered Press.
Oh.
Girl Powered Press turns your dreams into badass t-shirts, thus letting you sleep better at night and look cooler in the daytime.
Nice.
Girl Powered Press, official clothier of the astroquarks.
Oh.
So our sciencey news, we have several things we
We
mentioned.
sometimes do that on the show.
Sometimes have talk about
Have some
science
news.
related to the topic of the show.
Sometimes.
So we mentioned Jezero Crater, our sponsor.
How are we supposed to say it? Yezero.
Something close. It's,
Jezero.
We're both looking at it.
I saw something that said Yezedo, sort of. The
That's
R.
not what Wikipedia says.
Okay. But
If they're your sponsor,
Emily-
shouldn't you know how to pronounce this?
Emily Lakdawala, they didn't call me, they just emailed it. So
They didn't
Their
include
problem.
pronunciation.
Their
That's
problem.
right,
Yeah.
yeah. Emily Lakdawala at the Planetary Society had a phonetic spelling that was a little bit, had a D instead of an R.
Okay.
And then there was an audio file, but
Yeah.
every time I clicked it to play it, I instead got a Jethro Tull song.
Well, we need some of our listeners from Bosnia and Herzegovina to
There you go.
chime in and let us know
Yes.
There
how
you
badly
go.
we're wrecking this.
There you go. If you're listening from the Balkans,
Yes.
post a recording of the
Yeah.
correct pronunciation of this town which the landing site for Mars 2020 is named after. So that mission, the Mars 2020 mission, is the rover itself is basically a copy of the Curiosity rover.
It's very similar, yeah.
It has some different instruments. And will this one be doing the sample cache and storage?
It does the first part, yeah, where it samples and it caches it.
Gets some stuff and it puts it in a box and puts a little flag on it, says I am here.
Yep.
So that they can, some future astronauts can, or robot can go grab it and bring it back to the Earth.
Yeah.
And they chose this crater because it is
interesting.
When you look at it, it's quite clear that there was water flowing into it. It's something that looks very much like a river delta.
It's got a really cool delta.
Yeah, it's got this an outflow channel or whatever coming from the crater that is just blatantly, obviously, flowing liquid, or was flowing liquid. It's really very cool. We'll put up some images.
Right, and I think the chemistry of the rocks at the floor of the crater is favorable to perhaps longer preservation of biosignatures. So if
There's a lot of clay.
If life ever did arise there, it's a reasonably favorable environment for traces of that to still be detectable by the instruments that this rover will be taking. And of course, this rover was going to get some kind of name, I'm sure. Maybe Starship.
I thought it had a name,
Definitely not Starship.
but I don't remember off the top of my head.
When did they name Curiosity and the others? I thought it was after they launched even.
No,
Before?
it was before the launch.
Okay. We're still almost 2 years away from launch for this rover, though. We'll come back to that rover at our trivia.
Oh, and probably in a couple years.
And probably many times over the course of the next few years. The other Mars mission that's got news going on. Insight. So
not only news, there's also a really cool oatmeal comic about it. So I don't know if you guys read the oatmeal comics, but they're fantastic.
Yes.
And there's sometimes very interesting science facts hidden in them. But this one there's one all about Insight, and it has a robotic mole, and it's hilarious.
Oh, okay.
Great.
Right. So unlike Mars 2020, where they picked a very interesting place to land with water and all sorts of good stuff, Insight deliberately chose what they could determine as like the least interesting site.
Yeah.
Because they're not interested in anything going on the surface at all.
Yeah.
Right.
Which is weird for a planetary science mission. It's hard to get these types of missions where you go and look at like what's happening under the surface, and you're not just going there to you don't have a lot of spectra and pictures and things like that.
Right. So we've mentioned before that they're drilling down into the surface a little ways with a heat flow probe, so they'll be measuring how the heat is transported from the interior of the planet out, and then it's a seismic instrument as well. So it'd be listening for Mars quakes to try to understand the interior of the planet. So that's why it's called Insight.
Because it's looking
in.
Yes. Sighting in.
Yes.
Is Insight an acronym? I don't think it is.
I bet it's some kind of half acronym.
Yeah.
The S is capitalized.
Are there any other seismometers on Mars? Because don't you really need like a whole pile of them if you want to
you would like a network.
Learn a lot about
2 are much better than 1, 3 are much better than 2, and 4 are much better than 3. But you can do things with 1.
How much better is 5 than 4, though? Just a little bit better.
Yes.
But yeah, so you can still get good information with 1.
You still can get good information with 1. Yes. If you were to pick up a single earthquake which had shear waves in it, that would mean it was caused by something other than an impact, such as plate tectonics. That would figuring out what that was would be great interest.
And something we've never done on Mars. So there was Apollo missions had a little seismometer, but it didn't last very long. And they detected moonquakes.
Right.
There's a lot of speculation about whether that was impacts or internal
thermal
processes,
stuff
thermal
going on.
things. Yeah.
But
we've never done anything like that on Mars.
Right. So the main seismometer, the SEIS instrument, is to measure its main job, I quote, to measure the pulse of Mars by studying waves created by Mars quakes, thumps of meteorite impacts, and even surface vibrations generated by activity in Mars' atmosphere and by weather phenomena such as dust storms.
What? You can measure activity on the surface from dust storms?
Yeah.
They also have meteorological instruments to measure the wind, because the wind will give a reading the seismometer, and cleaning that type of noise out of your seismic signal is of interest.
There's a big delay in this launch, and part of it was because of the seismometer they have. So it's French built, and then part of the components are from the U.S., but it's basically like a little vacuum chamber, and it has to be good vacuum for the measurements, and they were having issues with it, I believe.
I can sympathize with that. I can totally, because never having made any kind of vacuum close to what they need to do.
Yeah.
Struggling just to get to the crappy vacuums that we need for our experiments.
Yeah. So this was supposed to launch in 2016 or something, right? So, but now
It got delayed 2 years. Because Mars launches...
There's every 22 months or so.
Yeah, because there's like good windows
For a good
an
planetary
optimal
alignment.
trajectory.
Right. But
Planetary alignment, actually a thing in launches, not a thing in astrology.
Right.
it's a thing.
It's a thing in astrology. It's just a meaningless thing. One of the other cool main instruments is the RISE instrument, the Rotation and Interior Structure Experiment. So I guess not the RISE experiment. It's the RISE.
It's the RISE.
Yeah. And it tracks the location of the lander very, very precisely, so which the lander sitting on the planet. So then you're measuring tiny, tiny changes in the rotation axis of the planet, which is one of the ways you figure out what's going on in the interior, because that's, I guess, the analogy that pops to mind is the game you play with an egg, spinning an egg, and whether it's a boiled egg or not, it spins differently. And planets spin differently depending on how mass is distributed inside them.
I play that game all the time.
Still.
This has been done with the Viking landers, which survived long enough that the orientation of Mars' pole changed while they were on the planet. This has been measured. This is a measure of precession of Mars' orbital axis, which constrains the interior, and the precision accuracy with which InSight will characterize this will be much higher.
Yeah, and it's impressive because precession is something that is cyclic but takes place over thousands or tens of thousands of years typically.
It's one of the things that messes up astrology.
Oh, nice.
Snap.
Yeah, it's like the spinning of a top.
Right.
It happens on Earth too.
Yes.
Yeah, and the other cool thing about InSight, right, which we've talked about before, is that there were 2 CubeSats that launched with InSight, and they went to Mars.
Marco
with
1 and Marco
InSight.
2, right?
Marco 1 and Marco 2, also known as Wally and Eve.
Oh, right.
And they should have been Marco and Polo. Still
Yes.
say that. But they're supposedly going to, they're hoping that they relay signals back as it's landing. InSight will be sending signals up to those CubeSats, and hopefully those CubeSats then help relay them back.
Cool.
So it's a technology demonstration, but it would be really cool if it gets that.
So more spacecraft going to Mars.
Woo!
Lots of spacecraft at Mars. There was a thing going around Facebook about how there's been
Mars
as much...
is going to be as big as the moon in the sky.
Yeah.
Yeah. No, it's not August or whenever
right.
it happens.
No, it was about how as much time has passed since people went to the moon as the time between, the time from the first airplane flight to human flying in space.
Wow.
Yes, words are complicated, man. That amount of time is equal to the time since the first people have flown in space. And where's the next big leap?
Right.
Yes.
Since then, it's like, hello, iPhones.
Well, this is just airplanes and spaceships.
For example, we now have multiple spacecraft operating at multiple locations throughout the solar system. Not just at Mars, but a bunch at Mars, rovers driving around on Mars.
Yeah.
Which brings us...
So that was an XKCD comic. And it was very, it's very human-centric, right? So it's talking about airplanes and spaceships that carry humans. So, because the first human space flight was April 12th, right? There's no arguing that there were spacecraft before that, and there have been many spaceships that do things in the meantime.
Right.
And go cool places.
Yes, and do cool things. And there are a lot of them out there. I mean, we've got spacecraft who are studying the Earth and looking at how the climate is evolving and studying the Sun and en route to Mercury. And Pepe Colombo's en route to Mercury, and asteroid sample returns, all sorts of cool stuff going on.
So exciting.
But speaking of the Mars rovers, before we get to our Gaia dark matter story.
Ooh, dark matter.
I was real thrown off by the Gaia reference. I was like, wait, which story is that? I forgot it was the dark matter story.
It's a Gaia dark matter story. So before we leave the solar system, we will segue to our trivia, which is Mars rover related. Yes, it's a trivia in 2 parts. As it frequently is. What is the...
Hold on. Don't blab the answer.
If you know Brad is likely to know the answer.
Likely to know the answer.
Keep your trap.
If it's trivial, I might know.
That's right. So keep your mouth shut. We'll come back for the answers later.
Yes.
First part, what is the top speed of the Mars Curiosity rover over flat terrain on Mars? So if it's just, here you are, drive, how fast do they drive it? What's that top speed?
Yeah, who knows?
Part 2 is, if you take into account all of the pit stops that the rover has made over the course of its time on Mars, and the Mars Curiosity rover's been there several years now, what has been its average speed over the surface of Mars? So there are 2 speeds we're looking for. One is, if they
Is
say...
this pre or post dust storm?
This isn't dust storm related for Curiosity.
Didn't Curiosity have to stop also for the dust storm?
Maybe.
Not like significantly.
But the average speed is based on just a couple months ago.
And do you mean average speed or average velocity?
I mean average speed.
Okay.
I mean distance traveled.
Total distance traveled divided by total time.
As if it's going to make a difference to
I
your
don't think it makes a difference in
guess.
your answer.
Sure it does. Total displacement, if it's as long
Yeah,
as
but
it's not
do you know
smaller.
those things?
No, you have no idea what either one of those answers is. You
Oh my
just
god,
know
I'm
that
gonna
one
rock
is,
your friggin' worlds.
you just know that one of them
I
is
am-
smaller than the other. You just know one of them is smaller than the other.
Your lack of confidence in my knowledge of what the rovers have done is shocking.
But also probably accurate.
Accurate, but shocking.
I'm shocked how well you know my
Yeah.
level of ignorance
Yes.
about this particular topic.
Yeah.
I thought I'd
How,
done a
after
better
all
job.
of these years, would you possibly know that I know nothing about that?
I thought I'd done a better job of concealing my ignorance
Yeah.
on this topic. Well, something you're not ignorant about is dark matter.
Ignorant, less ignorant maybe.
Aren't we all a little ignorant about dark matter?
Very.
Yeah.
Yeah, well,
Okay.
So there was a cool headline recently. So, I mean, the headlines are, of course, different at every different news site you go to. But I was looking the other day just randomly at CNN.com, and I saw the headline, which was very
You
scary.
saw science on CNN?
Science on CNN.
Wow.
A dark matter hurricane is headed our way.
Yes.
That was the
Darn
thing. And
it,
I was like,
Florida!
oh my gosh, this
Yeah.
is very scary. Because we live in Florida. Maybe for other people that's not as scary, but it's very scary when a hurricane's headed your way.
I got to board up the house.
Yeah, you gotta
Dark
board up the
matter.
How'd you board up the house for dark
Dark
matter
matter.
hurricane?
Dark matter. And that sounds like way scarier than just a
Yeah.
regular
It would be.
hurricane.
You
Dark
would,
matter hurricane.
so how would you, because dark matter is probably weakly interacting massive particles, right? These
Maybe
WIMPs.
that's one of the possibilities.
One of the possibilities. That's, if you were a betting person, that's probably where you would
Well,
put your money.
I think a lot of the people that wrote this
Just
paper
say
talking
yes.
about yes. WIMPs.
So you can set up my joke here,
Okay.
please. It's probably weakly interacting massive particles.
Yes.
So weakly interacting means it passes through stuff.
Yes.
So how would you board up your house effectively against those dark
You need
matter
thousands of light years of lead.
There you go. Thank you.
Something like that, yeah.
Great.
We
So,
could have gotten to that.
Get on that. I don't know
much
if they have
faster.
that at Lowe's or not. If they have
you
like
might have
1,000
to-
light year
you
thick
might have
sheets.
to order it ahead of time.
Yeah.
Thousands of light
They're
years
going to
of
run
lead.
out.
Yeah.
You know what would happen to that lead at the surface of Venus, Brad?
Melted.
Yeah. So the people who live on Venus are screwed. They're not going to be able to
They're not
walk.
going to be able to block this
They're
dark matter
building up
hurricane.
their big window shields of lead, and it just drips down the side of the house.
Aw.
Have you thought about millions of solar masses of mass in order to gravitationally deflect the
Oh,
Ooh.
I see the next like Armageddon coming.
Right.
All right, so what this really is so this, like I said, is the result of the Gaia mission, which is measuring.
The Gaia
The
mission
positions
caused
and-
this hurricane of dark matter?
No, but it sees that the stuff is coming. So it's looking at the positions and velocities of all stars in our neighborhood, and what you can get from that, if you look carefully at the data, is you can find that there are like groups of stars that are kind of moving together. And what we found is this pod of stars called the S1 stream,
Oh, what a great name.
which is stream 1. That's
Clever.
which is a bunch of stars that are kind of all clumped together and heading our way.
Nice.
Um,
It's a couple hundred stars or so.
Yeah, it's something like 90-something stars or something like that that are clumped together. And what we think this is part of was, the thing about these clump of stars is they're all moving the opposite direction as the majority of the stars in our galaxy, right? We
No.
generally, most of the stars in the galaxy orbit around the common center of the galaxy in roughly the same direction,
But
much
not-
like a solar
You're
system.
moving your hands the wrong way, though.
I'm looking from the South Pole.
Okay.
So, like in our galaxy, it's just like the solar system, everything kind of orbits roughly in the same plane and roughly in the same direction. But this pod of stars is going the other way.
They're from England.
That's right there. It looks like a vermilion.
They're on the wrong side of the road.
But what that means is they must not kind of have been part of our galaxy. So they must have come from some other source. So yeah, they're interlopers, most likely from a dwarf galaxy that we have kind of cannibalized over the course of the galaxy's history. And dwarf galaxies are notorious for having rather large amounts of dark matter compared to.
I think that's
regular galaxies.
They're notorious.
Not notorious.
I don't know.
Sure.
It sounded a little bit
I like it.
prejudicial against
Oh,
dwarf galaxies.
I apologize,
I don't
dwarf
think
galaxies.
that's-
I think it's pretty cool to have a lot of dark matter.
Yeah.
And so anyway, they have a lot of dark matter. They're and so
Proportional.
this is a little bit. All this stuff is a little bit
Proportionately.
hypothetical
What is
because
the proportion of dark matter to non-dark matter in a typical galaxy and in a dwarf galaxy?
so
it's larger in a dwarf galaxy.
right. So it might be there might be 6 or 8 or 10 times as much dark matter as normal matter in a regular galaxy, and there might be 10 or 100 times as much dark
Whoa.
matter as normal matter in a dwarf galaxy.
Wow.
Which would indicate, if these glob of stars are from a dwarf galaxy, that they're going to be accompanied by
1,000 or 10,000 times mass of the sun in dark matter.
right, a lot of dark matter, and that's headed our direction, and that's
Scary.
kind of nifty.
Hurricane.
Hurricane.
Dark
Hurricane.
matter hurricane.
Now
Why is it a hurricane? Is it also spinning?
we should be careful.
Is
to
it
note.
Spinning?
No, it's not spinning. Right? It's just like a big pile of dark matter headed our way. It's very
Okay.
scary. Of course, that will have
Very
absolutely no impact whatsoever on our solar system.
Is it going to hit our solar system?
It's absolutely. It's in the process. The fringes of it are hitting our solar system now.
I thought
It's
I felt
happening.
something.
Yeah,
on the way in
on the
this
way in
morning.
from work. Yeah.
Yeah. So, does this enhance in any way our ability to detect dark matter?
Possibly. So this is the only real news. Right? The news isn't a danger for us. Obviously, these stars are widely spaced, and so none of the stars are going to hit us. The dark matter is irrelevant because the density of dark matter is tiny compared to the density of regular matter. So it doesn't matter. But you're right. It will help us possibly detect dark matter. So there should be a kind of large density of dark matter coming from one direction, right? Coming from the direction of this pile of stars.
So we're
And
just
because
looking-
some of our
We just look in that direction.
we just look at that. So we have,
Well,
these
dark matter
detectors trying to look for dark matter. Some of them are looking for these things WIMPs. Some of these things are looking for other candidates called
Machos.
axions. No,
See,
we're
I
not
feel
looking
like we
for
haven't
machos
talked
are
about
done.
axions much on here.
No, we
Can you
don't
tell us
because
real quick about axions
sure,
that are
so-
not the things in your body?
so
Because I talk about
Right.
axions in
Axions.
like physics too, because they're like part of your nervous system.
right
Axons.
Axon.
I know.
axons.
Just making sure the listeners, I knew you
Axons.
knew. Just
Yeah.
make sure the listeners knew.
Axons.
What are axions?
Axions are hypothetical particles. I don't know if they're real or not, but they're hypothetical particles
Okay.
which are very much lighter. So WIMP stands for
Weakly interacting, massive particle.
massive particles. So the mass of those particles is rather large compared to something.
I was going to ask you what something is. I was like, yeah, how
Compared
massive
to other
are
particles?
WIMPs?
Well, compared to a typical
quarks.
quark or something like that, they're much more massive than that,
They're
but
not very massive.
interact very weakly, or interact only through the weak nuclear force, which
Right,
is why they're
which is
weakly,
pathetic.
which is very weak compared to the strong
I
nuclear force.
scoff at the weak nuclear
Um,
force.
But axions are much lighter particles, so you're gonna have way more of them if they're going to be the dark matter.
Mm.
But they also are just these. It's kind of these fundamental particles that are hypothesized to exist to solve some problem in particle physics. So the particle physicists came up with the idea of this, and it was one of these things where we latched onto it and said, "Oh, if that's real, and they exist in the right quantities, then perhaps they are dark matter, the thing we're looking
Particle
for."
physicists are always just coming
Latching
up
on to stuff.
no, coming up with things.
But the nice thing about axions is they have a good way, and I don't think I'm going to be able to properly, I don't think I understand it well enough to explain it, but I think they have good ways of
Don't let
detecting
that
them
stop
if they do exist. Because axions, if you have a very strong magnetic field and an axion goes through it, it does something. Like
What does it do?
converts to gamma rays or something. I don't know what it is.
It becomes something easily detectable.
It becomes something detectable. And so axions, if they are real,
Oh.
and you can detect them directionally. That is, you can see what direction they're coming from, and that's the thing about this thing. So if dark matter is axions, which again I don't know how likely that is, but if they are, then there should be a much greater number of them coming from the direction of this blob that's attacking us
Right.
now than from other directions. So there'll be some asymmetry in the direction, and then that
But
will
we
be
still have to
telling.
detect an axion at all to begin
Right.
with. And If
So-
dark matter turns out to be WIMPs, the directionality doesn't matter because this stuff's passing through everything. You can't tell which way it's coming from.
Right. Well, we have some.
Still
We have some.
asymmetry.
Try.
Right?
We have ways that we're trying to detect WIMPs as well. I don't know how.
I have to say
How
the
far
names
along
of some of
those
the
things are.
instruments that are being developed to detect axions are pretty great. There's one called Mad Max.
Oh!
There's one called Abracadabra.
Nice.
They're all acronyms.
Awesome.
Yes.
There are instruments being built that are being used in hopes of detecting WIMPs, where what they are looking for is correlation of the flux rate with the year, because as with the time of year, as the sun goes around the Earth, if we are moving through a constantly one-directional a constant stream of WIMPs moving one direction throughout the year, sometimes we're moving toward it, sometimes away from it. This is
Oh, okay.
people are reaching here, but they are trying.
Yeah. I mean, it's kind of beautiful and frustrating because we're building all of these detectors and thinking about all these things, and we really don't know if any of these things have a real chance of finding dark matter. I mean, back to my graduate school days, which was 15 years ago or something. I had friends in there that were working on these axion searches, and every day I would be like, "Any axions? No. Any axions? No."
Yeah.
15
Those
years
guys
later, any axion? No.
Your grad school friends were having trouble getting any axion.
Oh! Ooh.
Oh.
And they still are.
Yeah.
That's pretty cool. Yeah, so Abracadabra and Mad Max use big magnetic fields to look for a change in electric fields. So, because that's what axions do. They sort of behave like a photon in a strong magnetic field.
Yeah, it has to be a really strong magnetic field. So they're
That's cool.
anyway,
That's cool.
that's
Yeah.
cool.
So, all right.
So keep your eyes out. Who knows?
Keep your eyes and your dark matter detectors out for the next. How long is it going to take for this hurricane to pass by us? Thousands, hundreds of thousands of years?
tens of thousands. Something
So
like
much
that.
data.
Yes.
Yeah.
That's the greatest proposal ever. So, submitting this proposal has a period of performance 10,000 years. We're going to come to our trivia before we talk about our last two bits of news, which are sort of on the planetary side. We got another super Earth
Another super Earth.
and a cool Earth
Everywhere.
discovery
Yeah.
in Greenland.
A super Earth discovery.
Hey.
Ah.
So our trivia, as you recall, was looking for two speeds, not velocities, Jim.
Okay.
Two speeds. The top speed that they would operate the Mars Curiosity rover on flat terrain on Mars. So I don't believe this is the top speed it's mechanically capable of, but it's its top operating cruising speed. I will accept your answer in miles per hour or kilometers per hour.
Oh, nice. So do I get to
I'm
go
a
first
generous-
because I know
I'm
the
generous
least
that
about
way.
these kinds of
Sure.
things?
Sure.
I say its top operating speed
Yes.
is 2.3 miles per hour,
Okay.
and its average speed is
It's average. So let's come back to
0.3
average.
miles per hour.
We'll come back to the average speed after, so I can give you the
okay.
time but yeah.
All right, 2.3 miles per hour.
2.3 miles per hour.
Miles per. I'm going with miles per hour because I'm rogue.
I think it's like. I'll stick with miles per hour.
Yeah.
I think it's like half a mile per hour.
Brad.
I will go with 0.23 miles per hour.
Oh.
Okay.
And
That's an oddly precise number.
Well, the
'Cause I said
2.3
2.3
is-
is-
it,
Oh,
it
it's
turns
going
out to
factors
be
of 10.
1 order of magnitude lower than the first guess, and
Okay.
a factor of 2 smaller than the second guess, which was a factor of 2 smaller than the first guess.
Yeah.
All kind of works.
Okay. It's a factor of 4 smaller.
4
than
smaller.
I said first guess.
There was a factor of 2 in each step from the first to the second.
No.
No.
2.3
I
is,
thought-
is not.
I can see.
2.3 is not
I can
twice
see.
0.5.
I can see.
Sometimes
And
it
you
is.
can't get to a factor of 10 from 2 factors of 2.
That's true also.
Correct.
Well, Brad, nevertheless, in spite of that error in
He's
math,
still correct.
you are the winner.
Yeah.
Woohoo!
very slow.
0.09 miles
Wow.
per hour.
How many kilometers per second is that? Kilometers per hour is that?
0.15.
Okay.
So now, the average speed that it actually has moved, taking into account that it's...
I'm glad that you give us a chance to correct our.
Yes.
As my average
That's
speed
right.
was higher than me.
The
So
next
what is the
one,
correct answer?
0.09 miles per hour.
Yeah, it's real slow.
That's 20 centimeters per second, 20 centimeters per second or something like that.
Yeah, I think the reason for my mistake, I'm going to give myself an excuse.
Okay.
It's not a really excuse, it's just
Okay.
lack of
Go
knowledge,
for
of
it.
course. But I give sometimes when I'm teaching physics classes, I gave them this past semester. I gave them a problem, which was, how fast can it be going, or if it's going a certain speed, and I think I gave it like 2 or 3 miles per hour.
Yes.
How far ahead do they have to be able to watch for a thing in order to tell it to stop if it's going to fall off a cliff or something like that?
Light travel time of typically 20 minutes or something.
Right.
Yeah.
So they had to.
All right. So anyway, as of Sol, 2,166.
Where Sol is a Martian day.
Thank you.
You're welcome.
What has been the average speed of the Curiosity rover? So the total distance traveled divided by the total time that it has been on Mars.
I thought you were going to tell us the total distance traveled.
I thought about it and I
That
decided
might
not
give
to.
away the answer.
That would be too much helpful information. So the average speed.
Okay.
Maximum speed is 0.09 miles per hour. I will go with an average speed of 0.09 miles per hour, despite my difficulty doing math in my head. I think that is somehow related.
I'm actually, unfortunately, going to ask you to give your answer for this part in meters per second.
Oh, God.
But a meter per second is about 2 miles per hour. So what did you say for miles per hour? What did you say?
0.009 miles per hour.
Okay, so about 0.02 meters per second.
Sure.
Addie.
I'm going to go with 0.01 meters per second.
Okay. Jim.
Fascinatingly,
That is fascinating.
yeah, he took my answer and then she took my next answer. So I'll go with.
You can say the same answer.
No, I'm going to go with a different answer. You said what?
0.01. 0.001 meters per second.
0.001. Okay, I'll go with 0.0005 meters per second.
Oh, okay.
3 zeros and a 5?
Yep.
You are our winner.
Yeah.
It's 0.00001.
Yeah, it's real small.
Meters
It's
per
a
second.
lot.
That's 100 microns per second, or the width of a hair per second.
But
It
it's
spends
a
most of its
bit
time
of a,
just sitting still.
Yeah, it's a bit of a
It's a
silly thing.
bogus.
If
sort of
you just
stat.
counted the time it was driving
That's right.
and the amount of distance it's covered, it would be a more reasonable number. But most of the time it sits there and shoots lasers at rocks, which is
Right.
pretty
It's a little
badass.
drill bit,
Awesome.
and it's
Little
sort
drill
of
bit,
redone. It's
And it goes,
drilling.
pew pew!
Right.
It's
Yeah. In fact, I
laser.
think it's been sitting still for 2 or 3 months now.
But I like this trailer. It's a good fact because when you think of the Mars rovers, their name is Rover,
Like
so you think of them just like
roving
covering
around.
huge amounts of distance over Mars. That's covered half of Mars in the time. No, but it's like this little tiny area that it's really visited because it's mostly
Sitting
just moving
still.
little tiny distances and then
Let me go look at
sitting
that
there
rock.
for a month
And
and
then every
checking it
now
out.
and then it'll do a big traverse. It'll say, okay, now I'm going to go, hundreds of meters or something.
Right, but big traverse is still not,
Not
it's
very
not like
far.
going
Yeah.
to grandma's house or
It's a
something like
stroll.
that. It's,
I think for
stroll around
reference,
block.
right, say I remember this, I guess in 2015, Opportunity finished a marathon.
Right.
So in 11 years, it went one marathon,
Right.
26.3 miles.
And Curiosity
miles.
has not yet done a half marathon. It's
Yes.
gone 12.27 miles.
So it's clocking though. Because how long has Curiosity been there?
It has been there 2,166 sols.
How many human days?
2,300 days, 6-7 years, something
Okay.
like that.
Okay, so similar then. Similar speeds.
Bonus trivia, how long is a sol? Duration of a Martian day.
so 23 and a half hours.
It's 20. Is it shorter or longer?
Yeah, this is the crux
I
of the
think
question.
it's longer.
Okay, could be.
I think it's 20.
It's close to 24 hours.
4.5 hours.
Okay.
24.6%.
Yeah.
Show off. 24 hours, 39 minutes.
Yeah.
So it's close to a Martian, it's close to a human day, and the people
An Earth
who...
day. It would
That's
be a
true.
human. It would be a human day for a human
It's-
living on Mars.
It's close to a dog day.
It's true. What about a dog day of summer?
So when the people who are operating on these rovers do shifts at JPL, they actually put themselves on the Martian clock.
Yeah.
So
Shift.
their shifts are based on the 24-hour and 40-minute day on Mars, because the rovers, being solar powered, are operating in the day and also needing cameras to see whatever's going on. Are operating in the day, so they want the same workers there operating those things in those days. So
It's got a screw with the
after
markers.
a couple weeks or
They
whatever,
shift off, I think,
you're 5 or 10 hours out of alignment with.
And then daylight
Everybody
savings
else.
happens, and
Right.
everything's
Yeah.
awful.
So our last little bit briefly, we had another super Earth. This one is notable because it was discovered around Barnard star.
Bernard?
Barnard.
I
Barnard.
always
It's
thought
not,
it
we're
was
not
Barnard.
Westworld.
And a super Earth, just as a reminder, is a planet that's more massive than the Earth, a little bit bigger and a little bit more massive, but not as big as Uranus and Neptune. So this particular one is maybe about 3 times the mass of the Earth. And Barnard star is interesting because,
It's the star. It's really close and it's moving fast.
right, and historically, we've mentioned before, Barnard star, before we had actually ever discovered any planets around other stars, was believed to be a star with other planets around it because it had a wobble in its path across the sky, but that turned out to be due to a companion star. But it also has planets. And, maybe I misspoke.
Okay.
Barnard star is the closest single star to the sun.
Yes.
So I was mistaken about
Because
it.
Proxima
Logical
Centauri
proper
is
motion.
still the closest.
Yeah, the Alpha
right?
Centauri system, which is a 3-star system,
Yeah.
is closer. Barnard star is about 8 light years away.
But I think it has a faster, I think it moves faster in the sky. It has a weird.
It does have the highest proper motion
Yeah, it has
because
a
it's
higher
moving in an
proper
odd
motion.
direction. So
Mhm.
its position across the sky is faster than those other stars.
Mhm.
And then bringing it back home to complete our walkabout the galaxy.
Wait, so we didn't finish talking about, so this.
Oh, I did, but you
Well,
go
okay.
ahead. You know the interesting things.
Well, I mean, so there was this, there's a super Earth that is thought to be detected around Barnard star, and it's this paper that came out recently hypothesizing that it's there. And again, it's like with a lot of these other super Earth planets, it's close in, so it's really hard to detect. But they used, I don't know, like 6 different instruments and complementary data and many years of data to try to identify this. So they used Doppler effect and redshift, and also I think some different methods to look for the star. So people are interested in looking at Barnard star because of this historic thought that it had a planet around it. So
And this planet's actually not in as close an orbit as a lot of the other ones we've
Yeah.
seen. In fact, while it's closer to its star than the Earth is to the Sun, it's colder than the Earth is because the
red
Sun is a cooler star.
Yeah, it's kind of neat. This is like the second closest star or star system to our own,
Mhm.
but it's not visible to the naked eye. You can't go out and see Bernard star because
It's
it's
so
far
faint.
dimmer than the naked eye
That's
limit.
what we call a red dwarf.
red dwarf. And so it's much cooler. So even though it's it's like 0.4 times the distance between the Earth and the Sun, so it's even closer than
Closer than Venus.
Venus.
Boom, bringing it home.
Bring it back. Bring it back.
Right. And speaking of bringing it back home, so back home in Greenland,
Where none of us are from,
no, but on planet Earth,
but on planet Earth,
uh,
they found a new crater.
right, an impact crater that's relatively recent,
Yeah.
apparently.
And it's one of the 25 largest impact craters on Earth, but we hadn't seen it before because it was beneath ice.
Right, and it still is beneath the ice.
Yes.
That ice for the next 10 or 20 years.
Couple
it's
years.
still-
At least a couple years.
it's still beneath that kilometer of ice, but
Mhm.
as that ice runs off, then once it does all run off, we'll see a nice impact crater there.
Yeah.
Uh,
And for now, there's like some simulations of what it looks like, and I think they did it using Ice Bridge, which is this. They're doing planes and different things, and also ISAT-2 is going to be part of this campaign where they're tracking over the poles and looking with different types of imaging. So they're doing LiDAR and they're doing
ice
Ground,
penetrating
yeah.
radar that can send long wavelength light through that ice to bounce off that surface underneath the ice and map out, say, oh, there's an impact crater there.
pretty cool.
Those impact craters, this one was produced by an impactor about a half a mile across, if I have that right, and that's big enough to create sort of local devastation, but probably not planetary scale devastation like the one that killed the dinosaurs.
Yeah.
Right, but probably planetary scale, small, minor climate changes, right? So
Yes, it could be quite devastating for, even, I mean, you would notice it planet-wide. So even recently there have been some volcanic explosions that have produced noticeable changes in global climate for short periods of time. It would be that sort of scale of thing, but not hundreds of years and
Right.
mass extinctions
Right, not a mass
across
extinction
all,
event, right.
all levels. Well, it may feel like you've ridden a NASA Speed Demon Rover across Jezero Crater. It's just been another episode of Walkabout the Galaxy. I mispronounced it. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com where you can also see our new WTG t-shirts. You can't get them yet.
Too many
see them.
T's.
You can see them.
Soon. It'll be coming soon.
We're also on YouTube at Walkabout the Galaxy where you can see our all-important hand gestures. Follow us on Twitter
At walk_the_galaxy.
where you can ask us questions and suggest topics that you'd like to hear us discuss. Our theme music was composed by Richard Bruce and our production assistant is Diego Rodriguez. Catch up on old episodes wherever you get your podcasts and write us a review of extraterrestrial music. Take a mood synthesizer to Devil's Tower, the Laccolithic Butte in Wyoming, and play it until a giant glowing ship of aliens comes to hear it. Thanks to Brad Sandor for joining us on this episode. I'm Josh Caldwell.
I'm Addie Dove.
I'm Jim Cooney.
We're the astroquarks signing off until the next episode of Walkabout the